All right, so you're writing this first equation above the first graphing grid that you have there. And as we go through this one, the minus 3 is going to operate a little bit differently from anything we've seen before. Because the minus 3, it's inside the parentheses with the x. And you're going to find that it doesn't necessarily happen quite as intuitively as you might like. And so for this one problem, just for this first one, I'm going to graph this one by making a table of values. Now, I'm not expecting you to make a table of values on these in the future or anything like that, but I want you to see why it does what it does. So to start with my table, I always like to start with a nice easy number like 0. So let's plug 0 in for x here. So I'm going to do 0 minus 3, which is negative 3. What's negative 3 squared?
9.
Positive 9, yeah. Because a negative number squared means you're doing a negative times a negative, which is positive. So we have the point then 0, 9. Okay, what if x is 1? Let's plug 1 in for x here. 1 minus 3 is negative 2. Negative 2 squared is 4. And we can keep going through making this table using the same rules. So next up, x is 2. 2 minus 3 is negative 1. And negative 1 squared is 1. Always positive when we square a number. All right, what if we plug in 3 for x? We do 3 minus 3. 3 minus 3 is 0. And 0 squared, of course, is still 0. Remember this one. This one's going to prove really important here as we go forward. But let's get the rest of the points so we can actually see what this whole graph will look like. If x is 4, 4 minus 3 is 1, and then 1 squared, that's 1, of course. Do the same thing for 5, plug in 5. What will the y value be? It'll be 2 squared, which is 4. And if x is 6, what will y be? So you do 6 minus 3, then you square it. It is 9. Now, if I plot these points, that's the graph we end up with. Now, of course, notice it's a parabola, that U-shaped graph, because it's squared. So anytime we have that squared in there, it's still that U-shaped graph. But notice how it was moved. That minus 3 moved it which direction? It moved it to the right. But that seems slightly counterintuitive, because we would think that minus would be going left, because yes, left is the direction of the negatives, but it doesn't actually move it that way. Why is that then? Remember on the table I said 3, 0 was a really important point? The reason is because 3 becomes our new 0. That's why it ends up being kind of the opposite. If I plug 3 in for x here, I do 3 minus 3, which is 0. That means that 3 is acting like 0. So it doesn't just say, okay, minus 3 is left. It's actually what makes it be 0. So it's actually going to be opposite. So if minus 3 moves it to the right, plus 3, that's going to move it to the left. And this is going to be true for every single function type here. Anytime we have minus 3 in with the x, that's what tells us it's left or right. It's in with the x. Minus moves right, plus will go left. No matter what function type it is, that is always true. Now with that in mind, we can start looking at graphing the other functions following these rules. So above your second graphing grid, please write down this equation. Y equals the square root of x plus 8 minus 2. All right, first up, in order to be able to make this graph, we got to figure out what do the 8 and the 2 do. So the 8, notice it's inside with the x. That tells us it's moving it in the x direction. And I know it's moving it, it's shifting it, because it's a plus or a minus. Every time you add or subtract, it's moving the graph, as opposed to like stretching it or something. So the plus 8, we know it's moving it. We know it's moving in the x direction, which is left and right. Which way is plus 8 moving it then? Is it left or is it right? It is left. Yeah. In order to go to the right, it would have to have been a minus 8. That means we're going to start by going left 8, and the minus 2, it's hanging on the end. It does what it did in the last unit when we learned about this. The minus 2 moves it which direction? Down. Because the minus 2, it's not in with the x. The minus 2 is hanging on the end, which means it's still going up and down. So how do you know which way it's going? First, if it's in with the x, it moves it along the x. If it's not in with x, it goes up and down. All right, so our first point then, left 8, down 2. So put your first point for this one at negative 8, negative 2. And as you're doing that, again, why does it go left 8? Well, if I take negative 8 and plug it in for x, negative 8 plus 8 is 0. So negative 8 becomes the new 0 point. All right, now from here, now that I plotted that first point, all the other points follow the exact same pattern that square root always has. So since it's going to be square root, from that point, I'm going to go over 1 and up how far? Well, what's the square root of 1? 1. So we go over 1, up 1. Square root, though, I'm not going to go over 2 next, because I don't know what the square root of 2 is off the top of my head. It's a decimal. It's ugly. So I'm going to go over a nice pretty number. What's the next number I can take the square root of?
4.
4, absolutely. So the square root of 4 is 2. So we go over 4 up 2. And notice when I say over 4 up 2, that's from that starting point. It's not from the last point, it's from the starting point. I go over 4 up 2. All right, so next up, I just went over 4. How far over should I go next? 9, yeah. Because I know the square root of 9 is 3. So I count over 9, up 3 from that starting point. And then oftentimes we have been able to just stop there. But in this case, we actually can fit one more point on the graphing grid. So what's the next number I can take the square root of? 16, absolutely. And the square root of 16 is 4. So count over 16 from that first point and up 4. Those are all of them that are going to actually fit on this particular graphing grid. So then go ahead and draw your curve that goes through them. Then check and make sure that your graph looks the same as what we're seeing up there. Next graph, we're going to be dealing with an exponential, seeing how it affects that. Of course, write down this equation above your third graphing grid. Now, because this is one of those graphs that I know tends to give us trouble, I do want to make sure you're solid on that first step. The first thing I like to do in graphing an exponential is to draw in that dotted line. You know that line where it flattens out along the left side? Where is that line going to be in this case? Well, normally it would be at 0, but it's been moved up how far? 2. So the first thing we do is we draw on that dotted line up at 2. Now, just at this point as you're drawing that dotted line in, what's that really tell us? It tells us already that I know the graph is going to be something like this. Because it's flattening out along the left side, and then it's just going up from there. But unfortunately, this graph that I just sketched in isn't super precise, because normally we would start here. Normally we'd start at 1 above the dotted line. But that point's being moved. This minus 5 is moving that. Which direction is the minus 5 moving it? Up, down, left, or right?
Down, left, right.
Well, it's in the exponent with the x, so that already makes it left or right.
Left.
And minus 5, remember, left, right's backwards from what we think. Minus 5, that's actually right 5.
What?
Because if I plug in 5, 5 minus 5 is 0. 5 is the new 0. Generally speaking, when you're going left and right, it's just the opposite. So minus goes right, plus goes left. All right, now from that point, to get the rest of the points, you could memorize the whole pattern but I don't really like to memorize the whole pattern. I just like to memorize a rule because it's fewer things to remember. So the way I remember how to draw an exponential is that I remember that since it's 2 to the x, that I'm doubling my height from that line as I go over to the right. So if I just went up 1, I'm going to double that. I'm going to go up 2. So there's our next point. Okay, I just went up 2. I'm going to double that now to go up my next point. So what's that going to put me at?
4.
4, absolutely. That's 4 above the dotted line. Notice by drawing in that dotted line, it makes it a lot easier to count it. Otherwise, I have to say, okay, I'm going to count up 4 from 2. So I'm going to go 2 and then 4, and it's just a lot harder to deal with. This way you can just do it visually. All right, I just went up 4. How far up should I go next? I'm doubling it. 4 times 2 is 8, which does fit on our graph just barely. It's right up there. Right, then on the left side, how do we get those points? Because sometimes this is the part that gives people trouble is, yeah, but what happens on the left side? Well, on the right side, I was doubling my height, right? I was multiplying it by 2. If I go to the left, I'm cutting it in half. I'm dividing it by 2. So 1 goes to a half. And then if I cut that in half, I actually get to a quarter. And if I cut that in half, I'm really close to the line. And as I go to the left, I'm just getting closer and closer and closer to that line. So at a certain point when you're like, okay, I got a really good idea about where this is in order to make that curve as smooth as I can, go ahead and draw it in and flatten it out along the line on the left side. That way we're showing it's getting closer and closer to that dotted line. But remember, it never hits it and it never crosses it. Because no matter what number we take, it's a positive number. If we cut it in half, we get a positive number. We don't get 0 and we don't get something below the line. So it just gets really, really close along the left there. Right, next step. Let's throw 3 transformations in on you. Write down the equation above your next graphing grid, and then see if you can make the whole graph on your own at this point, and then of course we'll go through it together after you've had a chance to try it on your own. Okay, so checking in. How do we start this one? Well, the first thing I'm going to do is I'm going to look and see where has that first point, where has that starting point been moved to. So I'm looking at the adding and subtracting parts here. So the plus 1. First of all, the plus 1, is that going to move it horizontally or vertically? Well, it goes along the x-axis because it's in with the x, so it's going horizontally. It's going over. Okay, but when we go over, which way is it going over? Is it going over left or right? To the left. Yep. It is going left because remember, plus goes left and minus goes right. By the way, that has nothing to do with the fact that this is absolute value. That is true no matter what the function type is. Okay, then the minus 5. Which way is the minus 5 moving? Up, down, left, or right?
Down.
Down. Yep. Because it's not in with the x. So it's got to be up or down. So first point, left 1, down 5. All right, so having done that, I know it's an absolute value graph, so I know normally it'd be a V shape that's going up 1 and over 1 on both sides. But I still have to account for the 3. The 3 is a vertical stretch by a factor of 3. That is, it is stretching it upward to be 3 times as tall as it normally would be. So instead of over 1, up 1, I'm going to go over 1 and up 3. But it's still going to be that straight V shape, so it's going to do that on both sides. Over 1, up 3 on both. And because it is straight, it's not a curve or anything like that. It is straight, so it keeps following that exact same pattern all the way along the line. So if I went over 1, up 3 to get to those, I just keep going over 1, up 3 to get the rest of the points in. And then because it is straight, please use a straight edge to draw those lines in. So for graphing cosine here, the very first thing I want to do is I want to draw in those guidelines. Now the first guideline we always draw in is the midline. Normally, if I didn't change my graph at all, normally the midline would be at 0, and then I'd be going up 1 and down 1 around that. In this case though, we've shifted our graph up and down. Which way is it going? Is it going up or is it going down? It is going up, and how far up? 2. So that midline then, it's moved from 0 up to 2. So the first thing you do is you draw in a dotted line up at 2. As you draw in these guidelines, make sure they are dotted or dashed, not solid, because solid means it is the graph. These are the points that are part of the graph. Dotted just means it's a guide. All right, now normally with a cosine graph, I would be going up 1 and down 1 around that center line. This one, it's not changed because it'd be the number out front of cosine that stretches it to change that. So my other two lines, they'll still be up 1 and down 1. So make sure you have all 3 of those lines drawn in at those locations. And again, the way I got it is start with the middle, and then I know that I'm going up 1 and down 1 to get the other 2. All right, having gotten that part, we now would think about where do we normally start. And normally I'd be starting right here. I'd be starting at the top of the wave, because remember, normally cosine starts at 1, which is as high as it goes. But in this case, it's not starting at this point. It will be starting still at the top, but the top is not at 0 anymore. The 180 is moving where the top is. The question is, which way is it moving it? Is this moving at 180 left or right?
Right.
It is to the right, yes. So first point goes right 180, and it's on that top line. Now, the reason why you draw on those lines is you don't have to keep remembering as you go and make the rest of this where you go from there. In fact, from that point, you're just going to put your next points all on the same pattern, and it follows the same pattern every single time. First point's at the top. So from the top, we go top, then middle, then bottom, then middle, top, middle, bottom, middle, top, middle, bottom, middle, top. It goes on forever and ever and ever. It follows that exact same pattern, both sides. So that's where your points should all go. And then once you've drawn in the points, yes, draw in the curve. All right, time for the next one. Please write down this equation above your next graphing grid. And see how far you can take it on your own, and then we'll, of course, come together and take a look at it. So the first thing we do is we want to draw on the center line. The center line is determined by how far it's been moved up or down. Notice in this case, it hasn't been moved up or down at all because there's nothing added or subtracted on the end of this. So our center line is going to be at 0. Notice since it's going across the axis, you got to be a little bit heavier handed with drawing it in. But then, how far above and below are we going? How far up and how far down should the other two lines be? It's all that number right there. It's all that vertical stretch. So it's 3. So this is your starting point. Draw those 3 dotted lines in. Middle one's at 0, then you go 3 up and 3 down. All right, from there, you don't actually need to know a whole lot more to finish off this graph. There's basically 2 things. The first of those is, what's the 270 doing?
Left.
It's moving it which way? Up, down, left, or right?
Left.
Left. It's in with the x, so it's going left. And the other thing that we need to know, where does cosine start? Does it start at the top, the middle, or the bottom? The top. So that means I go left 270 and put a point at the top. All right, so from there, we start at the top. Our next point, following that same pattern that I was telling you earlier, we go to the middle next. Every single point we put is at a 90-degree interval. So if I go over 90 from negative 270, I end up at negative 180. So I go and put the middle there, and then I go bottom, middle, top, middle. You know the drill, right? Just follows that same pattern of top, middle, top, middle, bottom, middle. Draw the curve in that goes through them, and you got your graph done. Those guidelines just make your life so much easier because you don't have to keep in mind, okay, now that I'm going over 90, how far up am I supposed to go? You just look and find either the top, the middle, or the bottom line. You don't have to worry about the numbers they're at anymore. All right. One last graph that we're going to do here together. Please write down that last equation above your next graphing grid. See if you can graph it all on your own first, and then I'll give a few little hints here and there as you go along to make sure you're on the right track. So remember that first step, drawing those 3 dotted lines. The first one you draw in is the middle. Figure out where the middle is for this. Middle is however far it's been moved up or down. All right, so where does that midline go in this case? It's determined by how far it's moved up or down. That's the -1. So first, drawing a dotted line down at -1. And then you're going to be drawing in 2 more dotted lines. It's just a matter of how high up and down are you going. And it's always the same above and below. All right, so how high up and down are we going in this case? It's always that vertical stretch. So it's the number multiplied, that's the 2 here. So we got lines that are 2 above and 2 below that midline. This is cosine. Where does cosine start? The top, the middle, or the bottom? Starts at the top. Yep. And so that top point that's normally right here, it moves which way, left or right? Plus 90 goes left 90, yep. So our first point goes left 90 on the top line, and from there we just follow our pattern. Top, middle, bottom, middle, top, middle, bottom, middle, top, etc. on both sides. Draw on each of the points so that you have something to target. That's why I always have you draw on these points at least, because it makes your curve much better. If you try to draw a curve in without these points, it's just kind of drawing it in fairly blind. It's hard to be accurate. Then draw on your curve, and you have your final graph.